Hello there, and welcome back to the Sleep Science. Tonight we're curling up with a cosmic bedtime story that begins, oddly enough, with a streak of light so faint it nearly got lost in the digital noise of a survey telescope. You can almost picture the scene. Midnight in Hawaii, the Atlas survey dome humming, its camera quietly gulping starlight like an insomniac pulling espresso shots. Somewhere inside those pixels lurked what would be whispered about as 3I/ATLAS, a supposed third visitor from beyond the sun's neighbourhood. Your first thought? You probably won't survive this data slog. It's 20-odd reports, thick and full of graphs, that look like EKGs from a very caffeinated squirrel. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And since I'm always curious, post your location and your local time in the comments. I love seeing where in the world you're tuning in from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You sit with the first stack of reports, and the language feels almost ceremonial. Discovery notices always have that mix of understatement and drama. Object detected at magnitude 18.4. Possible rapid motion. Further follow-up required. It reads like the start of a mystery novel, but with more Greek letters. You trace the timestamp. 2024's quiet calendar night suddenly imprinted with a possible interstellar visitor. In your mind, the telescope dome creaks open, mirrors gleaming cold, the stars overhead sharp as pinpricks, while on Earth a grad student stifles a yawn and scribbles coordinates. A mainstream historical fact slips in. Back in 1846, Johann Galle identified Neptune thanks to careful predictions and a sharp eye on a telescope. Another moment when one faint dot rewrote cosmic geography. That's the thrill here. The sense that one anonymous pixel might carry enormous consequence. The quirky detail? The Atlas software sometimes mistakes fast-moving satellites for asteroids, and there are archived moments where excited alerts turned out to be Elon Musk's hardware streaking through. It's oddly poetic that the boundary between interstellar and internet satellite can hinge on a few arcseconds. Historians still argue whether the very first comet ever spotted telescopically, in the 17th century, counts as a true scientific discovery or just lucky eyesight. That same debate flavour hangs here. Does catching a possible 3I object with automated code feel like science, or like stumbling into fortune? You sip the reports the way someone sips lukewarm tea, slowly, eyebrows raised. The narrative tone in the earliest memos feels almost shy. No one wants to shout, "Third interstellar visitor," and then be wrong. You imagine the internal Slack messages. Hey, might be nothing, but check RA 17 hours, December plus 12 degrees. That's the cosmic equivalent of texting your friend, "This cloud looks like a dragon." The data trickles in, positions, magnitudes, timestamps. A table like an accountant's ledger, but every number implies a tiny spaceship-sized rock skimming through your planetary backyard. Your eyes glaze, but your imagination leaps. You picture a dark shard sailing silently, indifferent to whether Earth creatures recognize it or not. The early announcements echo through mailing lists, and amateur astronomers spin their telescopes to confirm. It's almost charming. The big observatory pings, and then a farmer in Spain or a retiree in Arizona tries to catch the same speck. Somewhere a dog barks, a shutter clicks, and another data point gets uploaded. And here's your first joke. You realise reading these reports is like reading horoscopes, but written by engineers. Object shows non-stellar profile, likely to continue motion eastward. Translation: Gemini, your love life is a faint smudge at magnitude 19. Another joke sneaks in. You find one report where the software spit out an estimated size comparable to a refrigerator. You imagine extraterrestrials shipping IKEA furniture through the cosmos. Third laugh. The phrase, "further observations required," appears in bold italics so many times that you want to start a drinking game, though in this sleepy story you're sipping chamomile instead. The discovery night, then, isn't fireworks. It's more like someone gently clearing their throat in the dark. Might be something big. You can almost hear the sigh of the observer, scribbling logs while the dome motors rumble. Outside, the stars wheel on. Inside, another PDF gets born. You close the first batch of papers. Already the atmosphere is one of tension between wonder and caution. You remember that history often starts with dull clerical notes. The Wright brothers' first flight log simply said 12 seconds. Here too, a life-altering object might have entered the archive as 18.4 meg, uncertain. And as the fan hum in your own room reminds you, discovery nights rarely feel like epics in the moment. They feel like staying up too late, staring at flickering screens, and wondering if anyone else will believe what you think you've just seen. You lean into the next pile of notes, where the tone shifts from tentative announcement to storytelling. The first ping, the first detection, it becomes a kind of lore in the astronomy community, repeated like campfire tales. You can imagine someone years from now saying, "Ah yes, I remember the night we first logged 3I/ATLAS. I was on the graveyard shift, my coffee had gone cold, and the server nearly crashed." In truth, these moments are quiet and bureaucratic, but your sleepy imagination paints them with glowing starlight and hushed excitement. The reports trace how the object was noticed at just the edge of detection limits. Atlas had been sweeping for potentially hazardous near-Earth asteroids, not alien souvenirs, but the algorithms flagged a faint moving point. The first follow-up emails sound almost apologetic, as if saying, "Sorry to bother you, but the sky may have just coughed up something historic." You can see an observer rubbing their temples, trying to decide whether to call their supervisor at 3 a.m. or just mark it in the log and pray it still appears tomorrow. A mainstream historical fact sneaks in here. In 1930, Clyde Tombaugh discovered Pluto through painstaking blink comparator work, lining up glass plates and spotting a moving dot. The echo is clear, faint specks, cold nights, and the possibility of naming something that will alter textbooks. Quirky tidbit. One early detection report actually mistyped a coordinate by 1 digit, which briefly convinced a discussion thread that the object had jumped across the sky at near warp speed. For about an hour, the chatroom speculation was half Star Trek, half panic attack. Historians still argue whether comets spotted by the Chinese court astronomers 2,000 years ago count as true discoveries or merely records of obvious streaks. That same question buzzes now. Is a TLAS making a discovery or just catching what anyone with good luck could have? You imagine that first detection night in Hawaii. The air is still, the ocean breathes below, the telescope dome hums like a giant seashell. Inside, the monitors glow faint blue, and an observer yawns, half dreaming when the software pings. That sound, a simple alert, might be more important than any drumroll in a symphony. The early notes describe rapid coordination. Object appears to have unusual motion, request confirmation. The community leaps in. Other telescopes pivot, students tumble out of bed, and somewhere an old Dobsonian reflector gets dragged onto a driveway. Astronomy is sometimes less about solitary geniuses and more about frantic group chats, all pointing at the same faint pixel. Your first sleepy joke. You realise these discovery memos are written with the same politeness as bad weather alerts. Possible interstellar trajectory reads almost like light drizzle expected. Someone out there was underselling the most exciting sky dot of the decade. Second laugh. One amateur's log in the chain has the line, "Saw faint moving dot. Dog stepped on tripod. Had to restart." The idea that a wagging tail almost derailed science history makes you smile. Third chuckle. The notes list magnitude estimates with decimals, and you think, the Astronomers' version of Yelp reviews. This object, 18.4 stars out of 20. As you keep tracing the lore, you notice how quickly myth builds. Within a day, speculation threads sprout online. Was this the third interstellar visitor? A comet? An asteroid? Someone even posts a meme comparing it to a lost Amazon delivery. Humans can't resist storytelling, even when the raw data is barely enough to prove existence. You pause and think about how fragile beginnings are. A single cloudy night could have erased the trail. A software glitch could have tossed the point into digital oblivion. So many cosmic visitors may have slipped past unnoticed, like fireflies at the edge of sight. This one got lucky, or perhaps you did. The first ping becomes lore because people decided to treat it as lore. The observers sent their emails, the mailing list caught fire, and suddenly this tiny dot had narrative momentum. It wasn't just an asteroid anymore. It was a character in the ongoing saga of mysterious visitors from the void. Your eyelids get heavier as you imagine that night stretched out. Astronomers sipping lukewarm coffee, scanning coordinates, the dome creaking as it tracks, stars rolling overhead, and far below, waves brushing volcanic rock. The object sails silently, utterly indifferent to the human scramble, as if smirking, "Good luck, Earthlings." Now the paper trail thickens and you shuffle deeper into the stack where astronomers try to pin down the object's path. These early orbit determinations are equal parts science and wishful thinking. You picture them like bakers trying to shape bread dough that keeps springing back, numbers swelling, shrinking, wobbling as more data drips in. The first orbit fits come scrawled with caveats. Preliminary, subject to revision, do not overinterpret. And of course, you immediately overinterpret. The formulas spill across the page: right ascension, declination, residuals. The orbital solution looks neat in print, but you imagine the real vibe was frantic typing at 2 a.m, equations half blurred by yawns. There's always that classic scientist poker face, pretend the oven is perfectly preheated, when really the dough is sliding sideways and threatening to collapse. Mainstream historical fact for you. In 1705, Edmund Halley famously calculated the periodic orbit of the comet that now bears his name. His prediction that it would return in 1758 was vindicated after his death, cementing orbital mechanics as more than math tricks. You feel the same weight here, the attempt to tie one flickering dot into a narrative arc across decades or centuries. Quirky tidbit: some of the earliest orbit software still outputs in ASCII art graphs if you poke around the logs. Imagine an interstellar trajectory rendered like a 1990s smiley face. Somewhere, a grad student printed it out and taped it above their desk. Historians still argue whether Johannes Kepler's elliptical orbits were a stroke of genius, or the stubborn fitting of curves until something finally clicked. The debate mirrors tonight's papers. Are these orbital fits true glimpses of nature, or just humans wrestling with messy data until it looks neat? The reports list provisional orbital elements, eccentricity near or above 1, suggesting a hyperbolic flyby. You lean in, because hyperbolic means not bound, a visitor from elsewhere. But the uncertainties loom large. It's like trying to predict the path of a frisbee from just the first 2 seconds of its flight. Depending on wind, spin and dog enthusiasm, the outcome could be anywhere. You picture the astronomers passing the data like hot potatoes, each group running their own solver, spitting out orbits that almost but don't quite agree. A PDF here says eccentricity equals 1.02 plus or minus 0.03. Another claims consistent with long-period comet. You want to put them all in a room and make them hug it out, but instead they politely cite one another while disagreeing in equations. First sleepy chuckle. You notice one report literally says uncertainties balloon rapidly, and you imagine tiny cartoon balloons drifting up, each one labelled plus or minus 0.1. Second joke. You realise eccentricity greater than 1 sounds less like a math fact and more like a dating profile description. Eccentricity, 1.05, not bound. Here for a good time, not a long time. Third laugh. One astronomer's blog compared their orbital fit attempts to herding cats with calculus. The phrase stuck. You now see every dot of starlight as a smug tabby refusing to cooperate. As the orbit fits wobble, so do your eyelids. The text drones on about barycentric corrections, planetary perturbations, and parallax offsets. You barely follow, but the imagery lulls you. The object sails along a potential hyperbolic arc, slipping past gravitational pulls, while Earth's observers scratch their heads and feed more numbers into the machine. You think about how fragile predictions are. A tiny error early on balloons, what looks like an interstellar escape could, with a small tweak, settle into just another weird comet. The reports themselves acknowledge this, almost sheepishly. Further data required. That refrain becomes a lullaby, repeated page after page. Still, the dream of an interstellar visitor glows beneath the math. Each recalculated orbit feels like a tug-of-war between skepticism and wonder. Maybe it's just a rock. Maybe it's a messenger from deep time, carrying dust older than Earth. You lie back, listening to the imaginary whir of telescope mounts, and let the bread dough trajectories rise and collapse in your mind. Your eyes drift to the next bundle of reports, and here the tone shifts toward comparison. The astronomers can't resist lining up this newcomer, dubbed 3I/ATLAS, at least provisionally, against the 2 earlier celebrities, 1I/ʻOumuamua and 2I/Borisov. It's like the interstellar family reunion, where the first child was mysterious and aloof, the second was messy but undeniable, and the third is the awkward cousin everyone's still unsure about. The documents recap the story of ʻOumuamua, discovered in 2017, a cigar-shaped rock, or maybe pancake-shaped depending which paper you read, that sped through at hyperbolic speed. That one left astronomers arguing about whether it was comet, asteroid, or something in between, and sparked years of debate that still hasn't cooled. In 2019 came Borisov, a much more classic comet with a fluffy tail, giving everyone the yes, definitely interstellar moment they craved. Now 3I/ATLAS gets held up to both. Is it elusive like the first, or obvious like the second? Mainstream historical fact. When Halley's comet returned in 1910, newspapers spread both awe and panic. Some even sold bottled anti-comet pills, claiming to protect against poisonous tail gases. Humanity has always made comparisons, sometimes silly when new visitors appear in the sky. Quirky tidbit. One forum thread called 3I the middle child syndrome object. Not as mysterious as ʻOumuamua, not as photogenic as Borisov, destined to live in footnotes. Someone even photoshopped a family portrait with ʻOumuamua looking brooding, Borisov trailing dust everywhere, and 3I wearing a Hello I Exist badge. Historians still argue whether ʻOumuamua should have been classified as a comet despite the lack of visible tail, or as an asteroid with unexplainable behaviour. The very categories blur, and 3I lands right back in that fuzziness. You scroll the reports and notice how carefully they hedge. Brightness consistent with small comet nucleus. Trajectory compatible with interstellar origin, though uncertainties remain. It's as if the authors are whispering at a library table, afraid to speak too loudly. Yet between the lines, you sense the excitement. This could be another messenger from beyond the heliopause, slipping briefly into sight before vanishing forever. First sleepy chuckle. One paper literally wrote, ʻOumuamua remains an outlier in many respects, and you picture it standing in the corner at a cosmic cocktail party, refusing to mingle. Second laugh. Borisov, with its obvious cometary activity, was once described as like a comet from central casting. You imagine a Hollywood director yelling, "More tail! Brighter coma! Perfect roll camera!" Third chuckle. In one summary, 3I is described as neutral in colour, unremarkable in shape. Basically, the cosmic equivalent of a grey cardigan. Somewhere in the universe, this rock just wants to be left alone with its Sudoku puzzle. Comparisons run deep though. The scientists know 2 examples don't make a trend, but 3? That starts to hint at statistics. If the first interstellar visitor was a fluke, the second a lucky catch, then the third means they might be common. Silent drifters crossing our skies far more often than we thought. That implication buzzes beneath the cautious prose like a secret no one dares fully say. Your eyelids sink heavier as you imagine the 3 interstellar siblings. ʻOumuamua, slim and enigmatic, refuses to reveal its composition. Borisov, bright and dramatic, leaves a trail like perfume. And Atlas, quiet and grey, mutters, "Don't compare me, I'm just passing through." Yet here you are, comparing anyway, because that's what humans do. And as you drift with these thoughts, the reports blur together, each one layering more data, more comparisons, more maybe yes, maybe no conclusions. The cosmic family tree is still being drawn, and you, like the astronomers, are scribbling question marks in the margins. The next stack in your lap leans hard into process, the sausage-making of discovery. You follow how Atlas, the asteroid terrestrial impact last alert system, doesn't just watch the sky by chance. Its pipelines comb through thousands of exposures every night, picking out faint streaks that move against the starry backdrop. Each detection is scored, flagged, and passed to humans for sanity checks. On paper, it reads clinical. In your sleepy imagination, it's like a dating app for rocks. Swipe left on hot pixels, swipe right on possible comets. The reports describe that dance between automation and human eyeballs. The software is fast, relentless, and occasionally gullible. Humans are slow, grumpy, and distracted, but much better at spotting when a candidate asteroid is really just a cosmic ray glitch. Somewhere out there, grad students are squinting at zoomed-in star fields, eyes burning, muttering, "No, that's a ghost pixel." Next. Mainstream historical fact. In 1998, astronomers at Linear, another survey, used automated detection for the first time to discover near-Earth asteroids on a large scale, revolutionizing planetary defense. Since then, the machine plus human model has become the backbone of skywatching. Quirky tidbit. Atlas has more than once flagged an insect crawling across a camera sensor. Yes, somewhere a moth took center stage as a fast-moving object, almost tricking the pipeline into thinking Earth was about to be visited by an interstellar bug. Historians still argue whether automation is stealing the romance of astronomy. Was the age of visual observers, people camping out under the stars sketching comets in notebooks, more real than today's Python scripts? Or is science just evolving like telescopes themselves? You picture the control room, screens tiled with star fields, algorithms humming in the background. A new candidate streak appears, the code assigns it a high score, and a human leans closer, rubbing eyes. Might be real. That small moment, the yes-no nod of a tired astronomer, is the bottleneck where cosmic history either survives or vanishes into the trash folder. First chuckle. You notice one report where an astronomer admitted, initially assumed it was just another satellite streak. Translation, thought it was Elon again. The quiet frustration of living in a sky increasingly filled with Starlink trains is palpable. Second laugh. The language object flagged for human review makes you imagine a bouncer at a nightclub, arms folded, saying, "Sorry buddy, you look too much like a bad pixel." Third chuckle. An amateur observer in the chain bragged online, confirmed with my backyard telescope and 2 cats watching. You love the idea of feline co-authors, though they probably only cared if the telescope box was warm. What emerges is the odd intimacy between machine vigilance and human skepticism. The algorithm casts a wide net, pulling in every faint smudge. The humans prune it down, deciding what deserves follow-up. Somewhere in that churn, 3i/ATLAS survived the culling, slipping past false alarms and moth photobombs into the realm of serious science. You let your thoughts drift. The machine sees tirelessly, the human doubts endlessly, and together they just barely manage to catch a faint, fleeting visitor. The room hums with servers, the night air presses cold outside the dome, and the sky keeps throwing its quiet riddles. You imagine yourself at one of those monitors, eyelids heavy, cursor hovering over confirm, a click here, a sigh there, and history ticks forward one faint streak at a time. Now the reports turn to colour, literally. You read how telescopes began pointing filters at the faint dot, hoping to capture its spectrum. Colour measurements are the cosmic personality test. Is this visitor reddish like many comets, darkly neutral like carbon-rich asteroids, or something stranger altogether? The results, at least in the early notes, are frustratingly vague. Some describe the hue as slightly red, others say neutral to grey. One bold team even wrote suspiciously beige, which makes you laugh out loud. Beige, the cosmic colour of uncertainty. Mainstream historical fact. In the 1980s, when Halley's comet returned, spacecraft flybys revealed its nucleus was darker than coal. Scientists had long imagined comets as bright and icy, but the reality was grimy and dark, a revelation that rewrote how textbooks described these wanderers. Quirky tidbit? One observing log apparently included a note about the telescope operator wearing tinted glasses that night, which sparked an online joke. Did we just colour calibrate the universe through Ray-Bans? Of course, the actual data came from the instruments, not eyeballs, but the image stuck. Historians still argue whether colour indices alone can reliably distinguish between cometary and asteroidal bodies. The debate stretches back decades. Does redder mean icier, dustier, or simply more sunburned by radiation? And into that argument stumbles 3i, wearing its bland beige cloak like a trickster. You picture the process. A telescope slewing, filters clicking into place, exposures stacking up. Somewhere, a grad student yawns into their hoodie while data crawls onto the screen. GR index, 0.4 plus or minus 0.2. Not exactly a thrilling revelation, more like someone describing soup as fine. Yet behind those numbers lies a tantalizing mystery. First sleepy chuckle. You find one report that says, object appears slightly redder than solar, and you imagine the sun sulking, muttering, "Excuse me, I invented red." Second laugh. A different summary describes the surface as featureless, which is basically the polite scientific way of saying boring. You imagine this poor rock going on a first date with Earth astronomers and failing every small talk question. Third chuckle. An amateur blogger wrote that beige objects are the car keys of the cosmos. You can't unsee it now. This interstellar wanderer shuffling past in dad pants. The more you read, the more the ambiguity grows. Some data hints at organic rich material, the kind that turns reddish. Other spectra look flat, suggesting processed, sun-baked rock. Each telescope adds a brushstroke, but the painting never quite comes into focus. It's like trying to describe a stranger glimpsed only through foggy glass. You lean back, eyes heavy, and imagine the rock itself. Cold, silent, drifting. Does it know we're arguing over its shade? Somewhere, maybe light from distant stars has been painting it for millions of years until it drifted here, into our filters, into our reports. Beige or red, neutral or dusty. It shrugs and keeps sailing, uncaring about human categories. And as the reports blur into one another, you feel the tug of sleep. Beige, it turns out, is an oddly comforting colour for a bedtime story. Neither dramatic nor alarming, just quietly there, like an old sweater or the hum of your fan. Brightness plots now fill your vision, charts that look like a patient's heart monitor, only less dramatic and far more confusing. Astronomers track the faint fluctuations of 3I/ATLAS, plotting light curves across nights and telescopes. The reports describe gentle rises, puzzling dips, and the occasional sharp wobble. You stare at the graphs until your eyelids twitch, and all you can think is, this looks exactly like the slow oscillation of a ceiling fan blade wobbling just slightly out of balance. Mainstream historical fact. In 1969, when Apollo 10 astronauts orbited the moon, they reported hearing strange space music over their radio headsets, later traced to interference, but the description lived on. Light curves carry the same mystery vibe. Signal or artifact, data or noise. Quirky tidbit? At least one team uploaded their raw light curve with axis labels missing, leading a jokester on a forum to describe it as the stock market performance of beige comets. It briefly trended among astronomy grad students, who have questionable senses of humour. Historians still argue whether early comet brightness records, scribbled by 17th century skywatchers using quill pens, are useful at all for modern science. Were those old measurements accurate, or just poetic? The echoes of that debate ring here, with astronomers squinting at noisy data and trying to decide if faint wiggles mean physics or fatigue. The reports hypothesize maybe the object is tumbling, flipping unevenly as it spins, causing sunlight to reflect differently. Or maybe jets of gas are puffing from beneath the surface, dimly altering brightness. Or perhaps it's nothing more than atmospheric distortion fooling the detectors. The truth hides in those tiny ripples. First chuckle. One log includes the phrase, "Light curve shows low amplitude variability," which sounds less like a scientific result and more like a Yelp review of a nightlight. Second laugh, you realise that tumbling interstellar body sounds exactly like a rejected circus act. Ladies and gentlemen, presenting the beige tumbler. Third chuckle. In an amateur's notes, they simply wrote, "Object faint." Possibly me faint too. You feel that on a spiritual level. The curves stretch across the page, repetitive and hypnotic. You imagine yourself lying in a darkened observatory, ceiling fans spinning above, while the telescope tracks the sky. The object flickers, its light pulsing faintly, like a distant heartbeat you're not sure you can trust. The longer you read, the more you sense the mood of the reports. Fascination tempered with shrugging. Data inconclusive. Amplitude small. Further follow-up needed. They're like lullabies of caution. No bold declarations, just slow hums of maybe this, maybe that. And as you sink deeper, you realise the beauty is in the wobble itself. Not clarity, not finality, but the rhythm of uncertainty. Each dip and peak whispers that this visitor is alive in motion, even if you can't yet decode its story. Your own light curve, eyelids heavy, thoughts dipping, then rising again, syncs with the cosmic wobble. The object tumbles on, far away, its brightness charted but never pinned down, and you, here in the dark, drift with it into the quiet sway of almost sleep. The next bundle of reports arrives with equations scribbled in the margins, whispering about forces you can't quite see. They talk of non-gravitational nudges, tiny accelerations that don't come from planets or the sun but from subtler culprits. For comets, it's usually outgassing, frozen ice is warming, puffing jets like cosmic steam vents, pushing the nucleus ever so slightly off course. For ʻOumuamua, some argued it was radiation pressure, the gentle shove of sunlight itself, that explained its odd path. And now, with 3I/ATLAS, the same questions hum softly through the text. Mainstream historical fact: when Comet 67P/Churyumov-Gerasimenko was visited by the Rosetta spacecraft in 2014, scientists actually saw jets shooting from its surface. They measured the tiny push on the comet's motion, confirming what had been theorized for centuries. Seeing it with cameras made it real. Quirky tidbit. One team in these reports calculated that if radiation pressure was strong enough, the object would need to be as thin as a potato chip. They actually wrote sail-like geometry in a footnote. Cue the internet calling it a cosmic Pringle. Historians still argue whether ʻOumuamua's trajectory could be explained entirely by outgassing, even though no visible tail was ever observed. The debate remains unresolved, and 3i now slips into the same tug-of-war. Was it nudged? Or was gravity alone enough to explain its arc? You picture a cat tiptoeing across a piano. That's how delicately these forces work. A millimetre per second change in velocity, over millions of kilometres, makes the trajectory look completely different. The reports run simulations. If the object outgassed this much, it should drift like so. If radiation pressure played a role, it should bend like that. And in every graph, the error bars stretch like yawning mouths, wide enough to swallow certainty whole. First chuckle. One researcher described the object as possibly responding to subtle forces. You imagine it as a diva saying, "I don't respond to gravity, darling, only to subtle forces." Second laugh. Another summary used the phrase statistically indistinguishable from noise. You can't help but picture the object shrugging, "I'm basically white noise, deal with it." Third chuckle. In a late-night forum, someone joked that maybe the nudge came from space pigeons hitching a ride. It was downvoted, but not before making you smile. The uncertainty doesn't frustrate you, it soothes you. There's something comforting about the idea that even with our telescopes, our math, and our simulations, a pebble drifting through space can still thumb its nose at precision. The nudges are there, maybe, or maybe not. Like a whisper half caught in a dream, you'll never be fully sure you heard it. You lean back and imagine the rock silent and beige, slowly pirouetting as sunlight brushes one side. Maybe it exhales faint wisps of vapour, invisible to us. Maybe not. Either way, it sails on, its path shaped by whispers too quiet to pin down. And as you think of that, your own breathing slows, almost in rhythm with those imagined jets, carrying you gently forward into the night. You slide deeper into the stack and hear the papers wrestle with the central identity crisis. Cometary, asteroidal, or something in between. 3. I/ATLAS sits in the Schrödinger's rock box, simultaneously wearing both hats until someone proves otherwise. The reports describe faint hints of a coma, a possible hazy glow around the nucleus, but then note how quickly those signs vanish under closer inspection. If you squint, it's a comet. If you blink, it's an asteroid. The universe seems to be trolling. Mainstream historical fact. In 1801, Giuseppe Piazzi discovered Ceres, first thought to be a planet, then downgraded to asteroid, later promoted to dwarf planet. Categories in astronomy have always been slippery. Even Pluto can testify to that indignity. Quirky tidbit. A hobbyist observer reported that their neighbour swore they saw a tail through binoculars. Turned out the neighbour was pointing at a distant airplane contrail at dusk. Somewhere in the margins of discovery, mistaken tails sprout like weeds. Historians still argue whether comet/asteroid distinctions are even valid anymore. Many objects blur the line, with rocky bodies that sometimes sprout faint comae when warmed. Some propose lumping them together as active small bodies and moving on. The categories like bedtime may be more cultural than scientific. The language in the reports grows hesitant. Possible diffuse emission, no definitive detection, activity cannot be ruled out. These phrases land like shrugged shoulders, repeated in different fonts. You imagine astronomers lining up to testify in court. Your Honour, I cannot confirm or deny the existence of a tail. First chuckle. One paper notes that no gas signatures were detected, but leaves the door open for very weak activity. You imagine the object holding a cigarette behind its back, muttering, "No, officer, I don't smoke." Second laugh. Another note described the coma limit as below detection threshold, which reads like someone grading a test and writing, well, technically not wrong, just invisible. Third chuckle. An online discussion suggested labelling it cumtoid, which sounds less like a celestial category and more like a new brand of painkiller. You close your eyes and picture the visitor itself. Does it feel icy? Does it trail faint, ghostly vapours in the sunlight? Or is it just a dry, stony shard tumbling without flourish? Perhaps it's both, or neither, depending on how close you look. Like Schrödinger's box, the answer is hidden until the measurements collapse the uncertainty. And yet, as the reports fade into repetition, you find the ambiguity oddly comforting. Not every rock needs to fit a neat label. Sometimes it's enough to let it exist in the in-between, neither comet nor asteroid, beige and stubborn. It drifts on, a puzzle unsolved, and you drift with it, eyelids heavy, into that same grey zone between waking and sleep. The next round of papers is full of stacked images, astronomers layering faint exposures on top of one another to coax the object into view. Stacking is both art and math, like trying to hear a whisper in a crowded room by replaying the recording again and again. Every time you add a frame, the signal sharpens, or the noise grows bolder. The reports argue over whether the faint smudge they've revealed is a coma, a tail, or just a very patient hot pixel pretending to be famous. Mainstream historical fact: in 1882, during the Great September Comet, observers stacked glass photographic plates to produce the clearest images of its sprawling tail. Even in the 19th century, astronomers were already cheating with composites, long before Photoshop. Quirky tidbit: one amateur posted their own stack and forgot to align the stars first. The result looked like modern art, streaks everywhere, with 3i hiding somewhere between. Someone on the forum titled it "Cosmos After Coffee Spill," and it briefly made the rounds as meme wallpaper. Historians still argue whether faint photographic detections from centuries past are real, or just artifacts of chemistry and imagination. Was that dot on a 1913 plate a comet, or a scratch from someone sneezing mid-exposure? The same unease lingers in tonight's PDF stack wars. You picture the process: astronomers hunched at computers, clicking stack, then waiting as software churns. The screen refreshes, a faint streak appears, and half the room gasps while the other half sighs. Debates break out in comments and email threads. Is that signal? Is that noise? You can almost hear the pettiness simmering. Well, our stack shows activity. Yes, but only if you stretch the histogram until the universe cries. First chuckle. One researcher politely footnoted that a rival team's stack was likely influenced by variable sky conditions, which is the scientific equivalent of "bless your heart." Second laugh. Another paper referred to the object's faintness as a significant observational challenge. Translation: we barely saw anything, but please still cite us. Third chuckle. An amateur wrote, "Stacked until my laptop fan begged for mercy." You can practically hear the CPU wheezing like an asthmatic dragon. As you sift through the stacks, your own eyes start stacking images. The words blur, letters overlap, until the paragraphs look like faint trails across your vision. Signal or noise? It's hard to tell. Maybe the act of reading late into the night is itself a kind of stacking, layer after layer of faint impressions, hoping to resolve something meaningful before sleep takes over. And like the astronomers, you realize you don't need absolute certainty. A faint streak, a maybe signal, is enough to remind you that something real passed across the field of view. Whether or not the stack proves it beyond doubt, the story lingers, faint but undeniable. The next sheaf of reports buzzes with trigonometry and nervous excitement. Parallax measurements. Observatories scattered across the globe tried to nail down 3I/A TLAS's position by comparing its apparent shift against background stars. It's the same trick your brain uses when you close one eye and then the other. Objects jump relative to the background. For nearby asteroids, parallax is straightforward. For something interstellar, the jumps are tiny, easily drowned out by noise. Still, the astronomers tried, their data points scattering like breadcrumbs across the sky. Mainstream historical fact. In 1838, Friedrich Bessel was the first to measure stellar parallax, proving once and for all that stars lay at measurable distances rather than painted on a fixed celestial sphere. That leap literally redefined humanity's place in the cosmos. Quirky tidbit. One amateur group attempted parallax by coordinating telescopes in different countries, but one member accidentally uploaded their data using local time instead of universal time. For half a day, the object appeared to teleport faster than Star Trek warp drive. Correcting it brought both relief and embarrassment. Historians still argue whether parallax measurements in ancient Greek astronomy were a missed opportunity or simply impossible with their tools. Did Hipparchus really suspect the stars moved? Or was he satisfied with his spheres? The echoes return now. Do we actually have a parallax signal here? or are we stretching our tools to their breaking point? The reports describe early relief. The parallax baselines seemed consistent with a hyperbolic, interstellar trajectory. But then the numbers jittered, like dice on a tabletop. A few measurements disagreed wildly, sowing doubt. Forums filled with back and forth. It's clearly inbound from outside the solar system. No, the scatter's too high, could still be local. You picture weary astronomers clutching their coffee mugs, muttering, "Just stay still, Rock." First chuckle. One paper called The Discrepancies Dancing Residuals. You imagine tiny ballerinas tiptoeing across a chalkboard graph. Second laugh. An observer's note bluntly said, "Probably atmosphere messing with us again." Translation. Blame the weather. Always the safest scapegoat in astronomy. Third chuckle. In an online thread, someone joked that if parallax numbers keep misbehaving, maybe 3i is deliberately dodging triangulation to keep its address private. A cosmic witness protection program. As you read, you sense the cycle. Confidence, doubt, reassurance, then renewed panic. Parallax both calmed nerves. It matched expectations and stirred them again, because the scatter never vanished. The universe doesn't hand out clean geometry when you want it most. Your own gaze shifts slightly, from page to ceiling, ceiling to page. Parallax in miniature. The lamp seems to jump, the shadows shift. You smile faintly at the thought that the same trick has carried across centuries, from a person squinting at a tree branch to astronomers squinting at a faint speck 300 million kilometers away. And in that small realization, you feel yourself soften. The rocks dance, the data scatter, the restless debates, all of it reduces to simple geometry, played out across human patience. The object drifts on, keeping its secrets, while the parallax angles shimmer like lullabies of uncertainty. You ease into the next reports, and here the chatter turns aspirational. Radar. There's always that dream. Ping the object with radio waves, catch the echo, and suddenly you know its size, shape, even rotation. Radar has revealed craters on asteroids and measured comets with astonishing precision. But 3I/ATLAS. The geometry was cruel, too faint, too distant, too fleeting. The papers read like wistful wish lists. A radar campaign would have been ideal. Unfortunately, object unobservable by Arecibo. Transmit power insufficient. It's science written in size. Mainstream historical fact. In 1968, radar was first bounced off the asteroid Icarus, producing direct measurements of its distance and trajectory. That breakthrough turned radar into one of astronomy's most powerful detective tools. Quirky tidbit. One email chain joked about borrowing planetary radar time usually reserved for tracking space debris. Someone responded that scheduling committees were tougher than black holes. Once you're trapped in their bureaucracy, no signal escapes. Historians still argue whether radar facilities have been underfunded to the point of missing irreplaceable opportunities. The collapse of Arecibo in 2020 still sparks debate. Was it preventable, or simply the end of an era? Those echoes haunt every paragraph here. You picture the scene, a giant dish pointing at the sky, transmitters humming, waiting for a whisper to return across millions of kilometers. The reports admit it never happened, but you can almost feel the phantom data, the ghost echoes that might have been. Radar imaginations are almost as real as radar measurements. First chuckle. One summary says the geometry was highly unfavourable. You imagine 3i showing up at the worst possible dinner angle, hiding behind the potted plant so no one gets a clear photo. Second laugh. Another team wistfully noted that Goldstone may have attempted observations had scheduling permitted. You picture the antenna raising its hand in a staff meeting. Pick me, and being ignored. Third chuckle. An amateur wrote, "If we can bounce radar off Venus, why not this pebble?" Ignoring the tiny detail that Venus is the size of, well, Venus. The missed opportunity lingers. Radar would have pinned down so much, whether it tumbled chaotically, whether it was smooth or lumpy, whether the beige surface was coated in dust or ice. Instead, astronomers are left with silence. No echoes, no shape model, just longing PDFs. You close your eyes and imagine anyway. A faint chirp leaving Earth, spreading wide, brushing across the interstellar traveller, then returning as the softest heartbeat. It would have been a lullaby written in radio waves, but the night sky kept it secret. the object sailed past unpinged, leaving humans to guess in the dark. The next batch of notes feels almost playful. Astronomers chasing rumours of meteor trails, hoping 3I/ATLAS might have sprinkled Earth's sky with a little stardust. If fragments had burned up in the atmosphere, they could have left meteor showers, glowing arcs for anyone with patience to notice. The reports read like treasure hunts, combing through fireball camera networks, cross-checking timestamps, comparing flight paths. You imagine scientists hunched over maps with pushpins, trying to find any pattern that screams alien pebble. Mainstream historical fact: the Perseid meteor shower, beloved every August, comes from debris shed by Comet Swift-Tuttle. That link, meteors as comet crumbs, was first confirmed in the 19th century, a triumph of celestial detective work. Quirky tidbit: one fireball camera caught a spectacular streak, but follow-up analysis revealed it was a commercial airplane reflecting the setting sun. Even better, the paper's appendix included a photo of the guilty 747, wings gleaming smugly. Historians still argue whether ancient reports of sky arrows and dragonfires describe genuine meteor showers or just folklore. Were those blazing trails real comets' children, or storytelling sparks? The same question hums now. Did 3I leave a trace, or are we chasing mirages? The reports are clear. No confirmed meteor trails matched the visitor. Some bright fireballs came close in timing, but orbital reconstructions quickly excluded them. The scientists dutifully catalogue airplanes, Venus sightings, even an owl swooping past a rural camera that triggered a false alarm. Reading those footnotes is oddly charming, like an accidental field guide to night distractions. First chuckle, one analyst sighed in print that a local owl proved photogenic but unhelpful. You can almost hear the bird hooting, "Not Interstellar, but thanks for noticing." Second laugh. Another note explained how a dazzling streak was simply a slow-moving satellite flare. You imagine the satellite smirking, "Let them think I'm from beyond the stars." Third chuckle. An amateur blogger claimed to have seen a meteor with beige undertones. Beige meteors, surely the rarest breed of all. You lean back, smile fading into calm. The lack of meteor trails feels fitting. This traveller arrived silently, left silently, no crumbs scattered, no fireworks offered. A guest who slipped in and out of the party without touching the snacks. And as you think of that, the room around you grows softer. Your own ceiling feels higher, the hum of your fan blending with the imagined rush of meteors that never were. The owl, the airplane, the satellites, they all melt into a background chorus while the true visitor glides on untouched, invisible and quiet. Your breaths deepen. The words on the page stretch slower, gentler, like the tail of a comet dissolving into night. You realise this is a natural pause, a wind down written by the object's own refusal to leave dramatic trails. Just stillness, just drifting. So let yourself drift too. No streaks, no bangs, no proof demanded. Only a faint echo of maybe something, a speck among stars, and your body easing into rest. The object has passed, the sky holds no trace, and you are left with the quiet certainty that even silence can be a story. You pick up the next packet and suddenly the prose sharpens. This time it's about peer review versus preprints. On one hand, astronomers rush to ARXIV, posting their findings as preprints within days of observations. Fast, raw, caffeinated science, plots barely formatted, figures misaligned, conclusions wrapped in tentative. On the other hand, the journal papers trickled in months later, polished, footnoted, with referees demanding consistency. You can feel the narrative splitting in two streams, immediate gossip and long-term memory. Mainstream historical fact: Isaac Newton's Principia in 1687 was essentially peer-reviewed by a single person, Edmund Halley, who also footed the printing bill. Peer review was once informal, patchy, and sometimes bribed with wine. It only hardened into the system we know in the 20th century. Quirky tidbit. One early preprint on 3I/ATLAS had a figure mislabeled figure, 3 inches 3 times in a row. The internet pounced, and a meme was born. 3I, 3 figure, 3S as some called it destiny. Historians still argue whether peer review is truly a safeguard or just an academic hazing ritual. Does it protect quality, or stifle bold claims? That echo hangs heavy here. The cautious journals versus the preprints brimming with enthusiasm. You read one polished paper that begins, we caution against premature classification. It's tidy, calm, the academic equivalent of sipping chamomile tea. Then you glance at a preprint from the same week. Object likely represents third confirmed interstellar visitor. That's more like espresso shots at midnight. First chuckle, one referee comment, later leaked, asked the authors to tone down the adjectives. You imagine the scientists going back, changing exciting to mildly notable. Second laugh, a preprint author thanked my cat for sitting on my keyboard during the data run. The acknowledgement section is a wild frontier. Third chuckle, someone on a forum declared that peer-reviewed journals are like waiting for your bread to rise but forgetting you're hungry. The push and pull feels almost theatrical. Preprints spark the online buzz, draw amateurs into the chase, and light up headlines. Journals preserve the record, cement reputations, and file everything into the tidy cabinets of academia. 3I/ATLAS lived briefly in the gap between them, too fleeting for full digestion, too alluring to ignore. Your thoughts soften. Maybe this duality is the point. We need both the messy immediacy of people yelling, "Look, a thing!" and the calm of referees muttering, "Yes, but let's measure carefully." Science is a lullaby sung in two voices, one fast and bright, the other slow and steady. You imagine the object drifting, indifferent to publishing schedules, while humans below argue about formatting and adjectives. And you, nestled in the quiet, smile at the thought that even cosmic visitors must survive both Twitter threads and referees before they can live forever in our storybooks. The papers you leaf through now step sideways into history, past echoes of interstellar hopes. Before ʻOumuamua or Borisov, there were countless false alarms, each briefly hailed as exotic before settling into ordinary status. The reports invoke those ghosts to keep expectations humble. You feel the mood shift. This isn't just about 3I/ATLAS, but about centuries of yearning. Mainstream historical fact: in 1729, comet Sarabat, also called the Great Comet of 1729, blazed so brightly and moved so oddly that some speculated it must have come from interstellar space. It didn't. But it became one of the earliest candidates in the maybe alien file. Quirky tidbit: in the 20th century, at least one asteroid catalogue entry was left flagged as possibly interstellar for over a decade simply because no one bothered to update the database. For years, amateur astronomers whispered about it, until someone checked the math and sighed, "Nope, just eccentric." Historians still argue whether medieval chronicles of guest stars and hairy stars sometimes recorded interstellar passers-by, or merely routine comets. The line between poetic description and scientific evidence is forever blurred. As you read, the sense of déjà vu thickens. Each new visitor gets greeted with excitement, but history reminds you, many dazzling comets have strutted across the sky, and nearly all were children of our own solar system. 3I then sits in a long tradition of maybe outsiders who might after all be locals in disguise. First chuckle. One report quotes an old paper that solemnly declared, "Comet X/1892, F1 may have been of extrasolar origin." You imagine Victorian astronomers whispering, "Aliens, but with T." Second laugh. A blog post compared 3I's hype cycle to that kid in class who everyone swears moved schools, but keeps showing up on the attendance list. Third chuckle. Someone at a conference apparently showed a slide of past false alarms with the caption, "Interstellar or bust." A cheer and a groan rolled into one. You lean back, eyelids heavy, feeling the rhythm of history repeating. Humanity has always craned its neck at the night sky, ready to believe we've spotted something from beyond. Sometimes we're right, usually we're not. But the yearning itself is the point. It ties ancient stargazers with modern survey telescopes, all hoping for that one true outsider drifting by. And in that realization, your thoughts soften. Even if 3I turns out to be just another local masquerader, the story belongs to the same tapestry of wonder and error that has lulled generations into awe. The echoes of history are a lullaby, humming through centuries, coaxing you gently toward rest. The next folder hums with code and heat. Astronomers turn to simulations, running models of 3I/ATLAS's possible paths, how it might have entered the solar system, how it might leave, whether gravity ever tried to capture it. You picture long nights with CPUs grinding, laptop fans spinning like miniature jet engines, while grad students whisper encouragement to their machines. "Come on, just one more integration before sunrise." Mainstream historical fact. In the 1960s, the rise of digital computers transformed orbital mechanics. Suddenly, long-term simulations that once took years of hand calculation could be done in weeks or even days. Celestial dynamics as a modern field was born in that hum of vacuum tubes and punch cards. Quirky tidbit. One researcher confessed on a forum that their laptop overheated during a particularly ambitious simulation, shutting down mid-run. The post included a photo of the device balanced on a bag of frozen peas, emergency cooling in the name of science. Historians still argue whether simulations should be treated as evidence in themselves or only as illustrations of possibility. Do they reveal truth or just reflect the assumptions you coded in? That question hangs heavily in these reports, where every model seems to carry its own bias. The results vary. Some runs show 3i cleanly inbound from deep interstellar space, gliding through like a guest who won't stay long. Others allow for the possibility of an object born here, tossed into an eccentric loop and only masquerading as foreign. The graphs are hypnotic, arcs curling, trajectories bending, all painted in faint lines of probability. First chuckle. One author noted that a few simulated clones of the orbit escaped the solar system backwards. You can't help but imagine 3i moonwalking out of the neighbourhood. Second laugh. Another simulation tracked the object into the far future, only to find its path intersected with a virtual Jupiter that didn't exist because of simplifications. The authors called it an unphysical but entertaining outcome. Third chuckle, an amateur simulator wrote, "My CPU got so hot I think it's now an interstellar object itself." You imagine laptops quietly drifting beyond the Oort cloud, humming equations to themselves. You close your eyes and picture the simulations as dreamscapes, arcs and loops glowing in a dark void, lines weaving like silk threads. Some paths dive close to the sun, others sling outward, all of them ephemeral guesses. The fan hums in your own room, echoing the laptop fan in those late-night labs, and the rhythm of spinning blades blends with the imagined arcs of interstellar travellers. The truth may never be certain. Was 3i captured, ejected, or simply passing by? The simulations offer possibilities, not verdicts, and as you drift with them, you realise that uncertainty itself is a kind of lullaby. A fan's whir, a CPU's sigh, a rock's arc bending gently through the night sky, too vast and too subtle to ever pin fully down. The next set of notes you unfold feels oddly bureaucratic, all about naming conventions. Before anyone agreed on what 3i/ATLAS actually was, the label itself began circulating, an identifier that implied certainty. The reports grumble about this. Provisional designation adopted prematurely, IAU confirmation pending. You can almost hear committees sighing, trying to catch up with headlines that had already crowned the object as the third interstellar visitor. Mainstream historical fact. In 1930, when Pluto was discovered, newspapers rushed to print the name before the International Astronomical Union had formally signed off. Venetia Burney, the English schoolgirl who suggested Pluto, was immortalised faster than bureaucrats could draft minutes. Naming has always raced ahead of process. Quirky tidbit, an early draft email apparently referred to 3i as that Atlas rock thingy, a nickname that leaked and briefly trended among amateur astronomers. For a few weeks, rock thingy was almost as common as 3i/ATLAS in casual threads. Historians still argue whether names bias public and even scientific perception. Was calling Ceres a planet for decades what made it feel planetary until demotion stung? Does slapping interstellar in a label plant certainty where data is shaky? You flip through the dry formalities, designation request submitted, awaiting confirmation, prefix 3i reserved. Meanwhile, the internet ran wild, memes plastered with 3i/ATLAS, long before committees blessed it. It's like naming a baby before the pregnancy test is even confirmed. First chuckle, one referee commented. The label may be premature. You imagine the rock blushing, muttering, "I wasn't ready for this level of commitment." Second laugh. A forum user suggested an alternative name, Borisov's boring cousin. Harsh, but catchy. Third chuckle. Another joke that 3i stands for I, the object's way of shouting me, me, me across the cosmos. Names shape memory. To call it 3i/ATLAS is to fix it in a lineage, to elevate it from faint smudge to cosmic ambassador. Whether or not it truly belongs, the label itself nudges belief. You imagine astronomers sighing, "Well, it's already on the t-shirts, might as well make it official." As your eyelids grow heavy, you realise names are lullabies too. Whispering 3I/ATLAS has a rhythm, a cadence that feels real even if provisional. The rock drifts on, indifferent to titles, while humans argue over committees and acronyms. Beige, silent, nameless, or named too quickly. It doesn't matter to the traveller. But for you, the act of naming is part of the dream, a way of holding on to something fleeting before it slips back into the dark. The stack in front of you now is the strangest of them all, a roundup of weird claims. Every time a new interstellar candidate pops up, the fringe theories swarm in like moths to a porch light. You read the scientists' sober summaries, then the wild speculations they feel compelled to politely acknowledge. It's like watching professors tiptoe through a carnival, nodding at each booth without stopping. Mainstream historical fact. When ʻOumuamua was discovered in 2017, Harvard astronomer Avi Loeb suggested it might be an alien probe. That idea, controversial to say the least, sparked op-eds, interviews, and late-night talk show jokes. The debate continues even now, illustrating how fringe ideas sometimes shove their way into the mainstream. Quirky tidbit. Someone online proposed that 3I/ATLAS could be a hollow spacecraft carrying cosmic sourdough starter, seeding life wherever it went. Another suggestion was that it was a chunk of exotic ice made entirely of molecular hydrogen, which would sublimate invisibly, an idea serious enough to make it into published papers for ʻOumuamua, though skeptics rolled their eyes. Historians still argue whether fringe theories harm astronomy or help it. Do they distract from real work or keep imaginations limber? The same tension plays out here. Most scientists roll their eyes at alien sailboat claims, but quietly admit that exploring odd hypotheses sharpens their conventional reasoning. The reports list the exotic: radiation pressure sails, nitrogen icebergs, fractal snowflakes, even the cosmic trash theory, debris shed from another star's planetary construction zone. Each possibility gets a paragraph, a cautious nod, then a return to more observations required. You imagine committees writing these sentences through clenched teeth. First chuckle. One author called an exotic ice scenario plausible but untestable. You picture the rock winking, "Catch me if you can." Second laugh. An online commenter suggested 3I was a galactic DoorDash delivery gone wrong. Beige takeout, anyone? Third chuckle. A preprint FAQ literally included the line, "No evidence for aliens." That's the kind of disclaimer you never expect to see in sober scientific writing. As you read, the fringe doesn't bother you, it soothes you. The speculation is whimsical, half-dreamed, almost poetic. Maybe it's a sail, maybe it's ice, maybe it's dust, maybe it's just a rock, and humans are projecting stories onto it like children seeing shapes in clouds. You let your thoughts loosen. The weird claims flutter like paper lanterns across your imagination, gentle, silly, glowing. They don't need to be true to lull you. They just need to remind you that wonder thrives even in uncertainty. And so the beige traveller sails on, carrying both sober models and playful myths in its wake, while you drift in the same soft in-between, somewhere between skepticism and dreaming. The next stack of documents slows down, almost philosophical. They circle around one question: what actually counts as interstellar? The reports outline thresholds like a bouncer at a velvet rope, deciding who gets in. If the eccentricity is above 1 hyperbolic, it might qualify. If the inbound velocity is higher than the solar system could have granted, even better. But measurement errors blur those gates, and 3I/ATLAS sits awkwardly in the doorway, like a guest who may or may not be on the list. Mainstream historical fact. In the 1970s, the twin Voyager spacecraft were launched with enough velocity to eventually escape the sun's pull, making them humanity's first true interstellar objects, though artificial ones. Their golden records ride along as cultural hitchhikers. Quirky tidbit? An amateur blogger jokingly proposed a cosmic club card. Once an object crosses the escape threshold, it gets a punch mark. 10 punches, and you earn a free t-shirt that says, "Officially Interstellar." Historians still argue whether earlier comets with extreme orbits, like the Great Comet of 1843, should be retroactively considered interstellar. Some insist they were just long-period comets barely hanging onto the sun. Others suspect at least a few may have been true outsiders. the definition has always been a little fuzzy. The reports on 3I debate eccentricity values hovering around 1. Consistent with interstellar trajectory. Possibly long-period comet with unusual parameters. The numbers wobble in their error bars like someone tipping between two stools. You imagine the object rolling its eyes. Fine, call me whatever makes you happy. First chuckle. One paper footnotes that the designation interstellar is provisional. You picture a cosmic stamp reading temporary alien status approved. Second laugh. A conference slide compared orbital thresholds to the difference between a divorce and a long business trip. A little harsh, but it stuck. Third chuckle. A forum wag quipped, "Eccentricity equals 1. Congratulations, you're mathematically single. You close your eyes and let the criteria wash over you. Escape velocity, inclination, residuals. All the velvet ropes, all the gatekeeping math. And yet, in the end, the label feels almost optional. The rock doesn't care if humans call it interstellar or cometary or beige cardigan. It sails on either way. For you, though, the thresholds are comforting. Like lullabies, they give structure, a rhythm to uncertainty. You imagine each gate as a gentle checkpoint the rock passes through, its arc glowing faintly as it drifts across the cosmic club. Whether it's let inside or left outside, the story's the same. A fleeting visitor, a faint mark in our sky, and now, a quiet page in your dreams. The final stack of reports feels like a closing sigh. After all the coordinates, parallax fits, brightness wobbles, and beige jokes, the astronomers gather their thoughts into cautious summaries. You read phrases like provisional conclusion, data remain limited, object unlikely to be revisited. It's not fireworks, not a grand finale, more like a librarian quietly stamping a book before shelving it. Mainstream historical fact: in 1994, the Shoemaker-Levy 9 comet crashed into Jupiter, producing spectacular plumes visible from Earth. The event was explosive, undeniable, a cosmic exclamation point. In contrast, 3I/ATLAS is a comma, soft, passing, nearly forgotten. Quirky tidbit? One of the last circulated memos included a cartoon doodle of the object as a little beige potato, wearing sunglasses, with the caption, "Probably interstellar." Probably chill scientists do get whimsical when the data trail runs thin. Historians still argue whether ʻOumuamua's legacy is a paradigm shift, proof that interstellar debris streams past us regularly, or just a one-off curiosity. The same uncertainty will shadow 3I. Was it the third chapter in a growing saga, or a misfiled footnote? You notice how carefully the reports step around sensationalism. No bold declarations, just soft landings. Likely, consistent with, cannot exclude. The responsible tone is admirable, though it does feel like the scientific version of tucking a blanket around your shoulders and saying, "Let's sleep on it." First chuckle. One paper literally ends with the line. Further observations are unlikely. You picture astronomers putting down their telescopes like tired teachers saying, "Class dismissed." Second laugh. Another closes with, "This candidate should remain in the literature." Translation: "We may never solve this, but please don't throw away our PDF." Third chuckle. A conference speaker reportedly summed up 3I with, "If it was interstellar, it was boring. If it wasn't, it was boring anyway." Brutal, but honest. You let the words blur. The cautious phrasing becomes a lullaby in itself. Uncertainty wrapped in professionalism. Possibility wrapped in sleepiness. The object has passed. The papers are filed. The committees have moved on. Only you remain, eyes heavy, still holding the story. And so you form your own calm, provisional conclusion. 3I/ATLAS was a faint visitor, beige and stubborn. Perhaps from another star, perhaps not. Its legacy is not fireworks, but humility, reminding humans that sometimes the universe whispers instead of shouts. The hum of your fan merges with the imagined hum of telescopes shutting down for the night. The sky overhead is quiet, the report's finished, and your thoughts slow into silence. The story gently folds shut, leaving you adrift in a softer rhythm. The reports, the arguments, the charts, all fade into background hush, like papers settling on a desk after the lights go out. You let the details dissolve, eccentricities, magnitudes, uncertainties, all crumbling into the simplest truth that something once passed through our sky, and we watched as best we could. The visitor itself drifts on, farther now, into cold silence where no telescope follows. Beige, grey or red, comet or asteroid. It doesn't matter. What remains is the memory of watching, of caring, of looking up into a night sky that will always outlast us. That act alone is enough. Your breathing slows, sinking with the steady, endless glide of the object through darkness. Imagine it now, a pebble sailing far from the sun, wrapped in a blanket of stars, untouched by noise, untouched by debate. Just drifting, just being. The universe hums and you hum with it. The voices of astronomers fade, the footnotes vanish, the pages close. All that lingers is the calm certainty that mysteries can remain unsolved and still be beautiful. You are free to let go of conclusions, free to stop asking questions, free to rest. So let the night carry you gently. The fan hums, the stars wait, the visitor is gone, and you are here, safe, quiet, drifting into sleep.